Hi, and welcome to my video on maximum minimum value of a quadratic function. Maximum minimum point. Let's look at the maximum minimum point first of a parabola. The minimum point of a parabola. If a parabola opens up, then the vertex is a minimum point of the parabola. The minimum point is the lowest point on the parabola. If a is greater than 0, then the parabola opens up. The vertex is a minimum point. And when I say a, I mean a in the equation. So the equation could be a, y equals ax squared plus bx plus c. You could have the vertex form y equals a bracket x minus h all squared plus k. Or you could have y equals a bracket x minus s bracket x minus t, where s and t are the x-intercepts. This is the intercept form. Let's do some examples. Find the minimum point of each. Notice the minimum point is the vertex point, the lowest point. The lowest point is 3, 1. So the vertex is 3, 1. So that vertex is the minimum point because the parabola is open up. This vertex right here is there. So it's at -2, -3. So the vertex is -2, -3. And it's the lowest point because the parabola is open up. The lowest point on the graph is the vertex if it's a parabola. The vertex of this parabola is the opposite of +3 is a -3 and a -1. Again, reminder, when you put a -3 in the place of x, this becomes 0. 0 squared is 0. 6 times 0 is 0. So y is -1. So -3, 1. And that's the minimum point because a is 6 and that's positive. The parabola opens up like this. So it's a minimum point. So the minimum point is the vertex. The vertex of this parabola is x is 1. And there's a 0 understood on the end. When x is 1, y is 0. And again, a is 1. And that means the parabola opens up like this. So the vertex is the minimum point, 1, 0. Practice means pause the video and work out the answers. Find the minimum point of each. The vertex of this parabola is 1, 2. X is 1, y is 2. Parabolas open up, so the vertex is the minimum point. The vertex of this parabola is x is 1, 2, 3, 4, -3. So 4, -3 is the vertex, and that's the minimum point because the parabola is open up. And the vertex of this parabola, opposite of +6, is a -6, 4. And this is the minimum point because a is 1. Parabola is opening up because it's positive, like this. Therefore, that's the minimum point. And the vertex of this parabola is 4, -2. And its a is 3, positive. So the parabola is opening up like this. And so the vertex is the minimum point. Now, let's look at the maximum minimum point again, but this time we're going to just then we looked at the minimum point. Now let's look at the maximum point of a parabola. If a parabola opens down, I got opens down, I should have. That's part of my thinking I read it right, but I didn't. If a parabola opens down, then the parabola is a maximum point. Then the vertex is the maximum point of the parabola. The maximum point is the highest point in a parabola. If a is less than 0, then the parabola opens down. The vertex is the maximum point. And again, the a is in the standard form, ax squared plus bx plus c, or is in the vertex form, x minus h all squared plus k, y equals a, x minus h all squared plus k, or it's in the x-intercept form, x minus s, s minus, so a equals, y equals a times x minus s and x minus t. Standard form, vertex form, intercept form, x-intercept form, where a is less than 0, the parabola opens down, so we have a maximum point. Examples, find the maximum point of each. The maximum point is the vertex point. So the vertex of this parabola, x is 3, y is 2. 3, 2. So that's the maximum point. But the maximum point is the vertex point. The vertex of this parabola is x is -2, y is 0. And again, the parabola is open and down, so the vertex is the maximum point. And we have a vertex of this parabola. Let's see, it's going to be opposite of -1, which is 1, and a 3. And A is -2, so that means the parabola opens down, so it's doing this. So this is the maximum point in the parabola. And the vertex of this parabola, the vertex is x is -2, and the number on the end is a 0, and it's a negative. A is -1, so the parabola opens down like this. So that vertex that's in this parabola, which is -2, 0, is the maximum point. Practice means pause the video and work these out. Find the maximum point of each. So the vertex is the maximum point. So the vertex is 3, -2. So the vertex is the maximum point because it's opening down. There's no other point higher than this one. And the vertex of this one is x is -1, y is 3. -1, 3. And again, the parabola is open down, so the vertex is the maximum point. And the vertex of this one, well, if you think about it, we have to notice the x is missing, so plus 0x plus 2. So the vertex, if the x coordinate is 0 here, so the vertex is 0 and 2. Notice if you put a 0 in the place of x, then y becomes 2. So the vertex is 0, 2. Notice A is -4, so that means the parabola is opening down like this. So that's the maximum point of this parabola. And the vertex of this parabola is x is -3, opposite of 3, and a -4. A is -6, so the parabola is opening down like this. So the vertex of the parabola, which is right there, is -3, -4. Maximum and minimum point of a parabola is the vertex. Now we know what we practice finding the maximum minimum point. Let's find the minimum value. The minimum value is the y value of the vertex if the parabola is opening up or the value of a in the equation is greater than 0. So if the parabola is opening up like this, then this is the minimum point. So the minimum value is the y value. Or if you have these equations like this, which is the vertex form, and this is standard form, and this is the x-intercept form, and if I say a is greater than 0 in each of these equations, that means in any one of these equations, which represents the parabola will be opening up. So the minimum value is the y value of the vertex. The y value of the vertex. So what's the minimum value of each? So the vertex, if you look at it, the vertex is right here. The vertex is x is 2, y is -1. So the minimum value is y equals -1. The lowest value in this graph is the -1. All the y's in this parabola are higher than -1. The vertex of this parabola is x is -2, y is 0. So, and it's going up, so the minimum value, the vertex is the minimum point, so the minimum value is y equals 0. It's the y coordinate of the vertex. Y is 0. And the vertex of this parabola is opposite of -6 is 6, -2. And its A is 7, which means the parabola is opening up like this. That means the minimum point is the minimum point is the vertex. The minimum value of the parabola is y equals negative 2. The lowest value of this parabola, negative 2. The vertex here is opposite of plus 4 is a minus 4, comma 3. Again, A is 1, A is positive, so that means the parabola is opening up like this, going up. And that means that this vertex is the lowest point, the minimum point, and the minimum value is the y value of the vertex, 3. So the minimum point gives you the minimum value of the y. The maximum point gives you the maximum value of y that's in the graph. Find the minimum value of each. We have number 1. We have a parabola. The vertex is negative 1, 2. So the vertex is negative 1, negative 2. Sorry, negative 1, negative 2. Notice the parabola is going up, so we have a minimum value, and the minimum value is the y value. So y equals negative 2. The smallest value of y on this graph is negative 2, which is the y value of the vertex. The vertex of this parabola is 1, and x is 1, y is 4. And again, a is 2, so this parabola is opening up like this because a is positive. So that means the minimum point is the vertex, 1, 4, but the minimum value is the value of y, so it's y equals 4. And let's continue. We have a maximum value. So if the minimum value is the y value of the vertex, if she's parabola is opening up, the maximum value is the y value of the vertex when the parabola is opening down, or when a is less than 0. So the y value of a vertex is the maximum value if the vertex opens down, or the value of a in the equation is less than 0. So just to write out the equation again, standard form, a is less than 0. This parabola will open down. The vertex form, a outside of x minus h all squared plus k, where a is less than 0. Or if the equation is in the intercept form, x minus s, x minus t, and again, a is less than 0. So any one of these equations, if a is less than 0, the vertex is a maximum, and the maximum value is the y value of the vertex. Let's do some examples. State the maximum value of each. Well, the vertex on this parabola is x is 2, 3. So it's going down, so the vertex is a maximum, so the maximum value is y equals 3. The vertex on this one, x is negative 3, and y is 0. The parabola is opening down, so that's the maximum point. Vertex is the maximum point of negative 3, 0. So the maximum value of y is 0, is the highest value. The vertex on this one is negative 41, comma, and there's a number out here, 0. So the vertex is negative 41, 0. A is negative 3, means the parabola is opening down. So the maximum point is negative 41, 0. So the maximum value is 0. Y equals 0 is the maximum value of y. The vertex of this parabola is 7, comma 2. Opposite of negative 7 is 7. And a is negative 1. So the parabola is opening down. So that means the vertex is a maximum point. That's the maximum 2, 7 is the highest point. So the maximum value is the value of y in the vertex, so y equals 2. And we have some practice. State the maximum value of each. Pause the video and work out your answer. The vertex in this one, x is negative 3, y is 2. So the vertex is negative 3, 2. The vertex is opening down, so we have a maximum value. So y equals 2 is the maximum value of y in your parabola, as you can see. There's no other value of y higher than 2. The vertex of this parabola is negative 3, comma, negative 1. And a is negative 6. So that means the parabola is opening down. So that means the vertex is the maximum point of negative 3, 1. And the maximum value is the y value. Y equals negative 1 is the maximum value. Okay, let's do some more. Find each. Pause the video and work these out if you wish. The vertex of this parabola is 2, 4. So the vertex is 2, 4. Because it's opening down, the vertex is a maximum point, PT. And the maximum value is it a maximum or minimum? Was the maximum point, so it's the maximum value. Maximum value is y equals 4. Remember, the maximum or minimum value is the y value. Number 2, the vertex is -1, -3. So the vertex is -1, -3. Because the parabola is opening up, it is a minimum. MIM, point PT. And the minimum value is the y value. Y equals -3. We have a vertex of this parabola, which is 6 and a -1. Notice that A is 4. So this parabola is opening up. So that means if it's opening up, that means we have a minimum point. So therefore we have a minimum value of -1. Y equals -1. Because the minimum point is the vertex. The minimum value is the y value in that vertex. We have a vertex here of -4, 3. -4, opposite of +4 is -4, and a 3. And A is -8. So therefore, it's going to be a maximum. Because the parabola is opening downward, like that. The vertex is a maximum point. So it has a maximum value of y equals 3. And the vertex of this parabola is 1 and -4. A is a half. That means the parabola is opening up. A is positive. Positive means up. Negative means down. Think of it that way. And it's opening up. We have a minimum, MIN. We have a minimum point. So the minimum value is the y value of the vertex. Y equals -4. Number 6, we need to find the vertex. So the vertex x equals -b over 2a. So that's negative. A is -1. B is -6. So it's the negative of a -6 over 2 times -1. Oh, -1. So that's 6 over -2, which is -3. That's -1 there. So we plug a -1 into the equation. Y equals, -3 into the equation for x. And we square first. We get a 9, and we do the negative of it. So it's -9. -6 times -3 is 18. So the vertex is -3, 9. So that's and because A is -1, that means we have a maximum point, and the maximum value is the y value. Y equals 9. And we have another parabola in the standard form. So we have A is 3, B is -6, C is 3. And to get the vertex here, we just simply do the -b over the 2a. So negative of the -6, b is -6, a is 3, 2 times 3. That gives us 6 over 6, which is 1. And we'll get the vertex. That's the x-coordinate of vertex. So sub x equals 1 into the equation. So there's the equation. We found the x-coordinate of vertex to be 1, so we're subbing 1 in the place of x, done. So 1 squared is 1. PEMDAS, we do the square first. 3 times 1 is 3, minus 6 plus 3, because we've got to multiply after we finish that off. So that's 0. So the vertex is 1, 0. So because A is positive 3, we have the parabola opens up like that. There's the parabola opening up. That means we have a minimum point. So the vertex is the minimum point. Let's put the vertex here, which I have it down here, but let's put it here. The vertex is 1, 0, and it's opening up because A is positive, so it's a minimum point. And the minimum value is the y value of the vertex, y equals 0. Hopefully, you're understanding the maximum and minimum point of a parabola, the maximum and minimum value. And the last page, state the range of each parabola. We got to state the range of each parabola. Now the range is the y value. The range is the y values that we practiced in the earlier video. So if we have a vertex of 1, -4, and the vertex is a maximum, we could say maximum. We mean the vertex is a maximum. We could say maximum, you see that? Or you could, the vertex is a maximum point if you want. Then the range is the y value. So the range is the y value. The y value starts at -4. Because it's a maximum, that means that the parabola, that's the highest point in the parabola. That means the parabola is opening down because it's a maximum. So the y values are less than or equal to -4 for this parabola. And again, the vertex is a minimum point. We say minimum or minimum point, either or, whatever you want to say. If it's a minimum point, that means the parabola is opening up because the minimum is the lowest point, and the lowest point is the vertex. The lowest value is 3, so it starts at 3. It's the minimum point, so the y's are always higher. So y is greater than or equal to 3. The range is the y values that's in your parabola. Again, if it's a minimum, it opens up, so it's the lowest is greater than equal to. Again, opening up, up, greater than equal to. Opening down, down is less than. The vertex is 1, -4, and a is greater than 0 in this equation. Now, if a is greater than 0, that means a is positive. That means the parabola opens up. That means this vertex is a minimum point. So the values of y must be start at -1 and it opens up, so it must be greater than equal to. This vertex is 6, 2. A is less than 0 in this equation. So no matter what the equation is, if a is less than 0 in this quadratic equation, then less than 0 means the parabola is opening down. And that means it's a maximum. So the range is y is less than or equal to the y value of the vertex. So that vertex is 6, -2 if you did a graph. So the y values start at 2 and go down because a is less than 0, less than, I look at less than as being below, down. Greater than is like looking up. Greater than, notice, greater than 0, greater than or equal to -1. If a is less than 0, then the range is less than equal to the y value of the vertex. And state the domain of the parabola. Now, no matter what the parabola is, the domain of this is a parabola in vertex form, where the vertex is h, k, but we don't know what the vertex is actually as numbers because we don't know what h and k is. But the domain of any parabola is always x, e, r. The domain is always the reals. The domain is always belonging to the real numbers. All the values of x are in the graph of a parabola, whereas the range could be up or down. The range is the y values. Click on the button if you like my video, or click on the like button, subscribe button, notification bell. Visit my website www.mathfullyexplained.com to find more information about me, my videos, and the content. And that's the content is on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.